Good afternoon, everyone. Nana. Will we start the class now? Okay, right. Good, we'll start it now. Previously, I think I got some part of projection from the top of it. Good afternoon. I don't know to what extent you remembered related to that concept. Which kind of disturbance you are feeling there? Cerebrally? What kind of disturbance? Is it so? Good afternoon. Now is it not clear, my voice? When air is blown. That I don't know. Okay. Okay. Now what about? Yeah, yeah. Are you able to hear my voice now? Yes. Okay. Now is it clear? Right, good. Yes. All right. Previously, we discussed the concepts like here. Sorry. From the top of a tower. Suppose this is the top of a tower. From here, you are projecting one body horizontally, and in the previous class, I think you remember, follows one parabolic path like this, and finally hits somewhere here on the ground. Okay. And in its path, previously I explained clearly, at some time, some of air Now is it clear? Now? I think it is clear now. Yes, yes, yes. Good. So here, listen, Nana. After projecting, that is actually coming from fan, Nana, fan sound. Okay, no problem. After certain time, Nana, previously I explained on in Saturday's class, x is equals to, I don't know, you remembered it or not, ut, and y equals to, that is half gt square. Remember this part, Nana? Okay, okay, okay. Then the relation between these two also we did that day. Y is equals to half g by u square into x square. This one we wrote as ax square. Yeah, correct. Ax square, where a is equals to half g. I think g by 2. Right, correct. Where a equals to also correct. And I remember that I explained even the range also, the time. A range means this part, Nana. What the maximum horizontal distance it traveled. R is equals to, anyone remember? No, I think. Okay, range is equals to root 2 h by g. I think all of you forgot u. U root 2h by g, I think, if I'm not wrong. Yes, right, right. All of you forgot u there. Right, good. And yeah, u under root 2h by g, correct. And the time of flight also that day we discussed. Time to reach the ground. T is equals to root, this is root 2h by g. Yes, correct. Time to reach the ground. Okay. And velocities also I discussed on, I think, horizontal component of velocity and vertical component of velocity. Anyone remember? I think it is u, and this is, yes, yes, this is gt. Yeah, correct. This is gt. Very good. And here v vector form also, that day I told vx I cap plus vy j cap. U sin, not u sin theta, Nana Lakshmi Gayatri. U sin theta means with the horizontal when it is projected. Here angle of projection theta equals to 0 degrees now. Okay. Right. That is wrong actually. What you told. Right? Yeah, yeah. Correct, correct. So Vx I cap plus Vy j cap. And its magnitude also that day I told root of Vx square plus Vy square. Okay. And one more. The velocity vector at a point. That is also I explained that day. Velocity vector makes some angle with the horizontal. Alpha equals to how much? I think this was the last part I explained that day. Tan alpha equals to, yeah, correct. That is correct, Mr. Mok. Tan alpha is equals to Vy by V. Tan inverse. Yeah, correct. That is correct. Ishan. Easter Angelina. Okay, right. Vy by Vx. That implies alpha is equals to tan inverse Vy is Gt by Vx is U. Very good. So these were the parts what we discussed in the previous class. Okay, just to have a small glance here. Okay, previously. What we discussed related to this concept. Body projected from the top of a tower. Okay. So better we go through few numericals related to these concepts, what I discussed just now. Okay. Suppose if I ask one question here related to it, right? So again, are you ready? Yes, good. So ready. Right. Come to here. Example. A body is projected with a velocity 20 meters per second, 20 meters per second horizontally from the top of a tower of height 100 meters. Okay. Take as usual g is equals to 10 meter per second square. And here find out. Number one, I am asking. Find, here I better I write here. Find, number one, the range 40 root 5. Oh, time is root 5. Okay. 40 root 5. But I will check it. Range. First I go to the range. R is equals to, I have the formula U root 2H by G. Given information here, U is equals to 20, H is equals to 100, and G is equals to 10. Okay. That I don't know. All of you able to see the data here, Nana? Yes. Yeah. Right. I think there is some problem in your system, Mr. Archa, Miss. So here U is equals to how much, Nana? 20 root of, okay. 2, H is 100 by G. G is 10. So 20 root 20, correct. 20 root 20. That you can write it as, root 20. Yeah. You can stop there, or else you can write it as 4 into 5. Root 4 is 2. 2 into 20 is 40. 40 root 5. Even this is also correct. Okay, time is root 20. Yeah, correct. This is 40 root 5. First question, Nana. Okay. Second question, already you gave the answer here. Okay. That is second one. This is time of flight. Okay. Time of flight here, many already solved and put their answers also. The time of flight is equals to root of 2h by g. Okay. Yeah. Good afternoon. Root of 2h by g. H is 100 by G is 10. You are getting root 20. This is 2 root 5. Yeah, this is 2 root 5 seconds and that is 40 root 5 meters. Okay, good. Now the third question is, find, okay, fine. There may be some network issue at your, who is this Lakshmi Sujata? I think it is a problem with your computer or system or tab or mobile, Nana. Why? Because remaining students are able to hear and they are putting the answers also there in chat. So third one here, find the velocity, okay, after a time of 2 seconds. Okay, both on a magnitude and direction, both you have to find out here. Third one. So if I come to the third one, extra I got t is equals to 2 seconds. So Vx is directly itself u. No problem. It happens, Nana, sometimes, no problem. So Vx is equals to u okay, sorry, Nana. Vx is equals to u, that is equals to 20 meters per second, and Vy is equals to gt. It is already there on the board. Okay. G is 10 and T is 2. That is equals to 20. Vy is also 20 meters per second. Yeah, Amog, Mr. Amog, you are right. And 45 degrees. Very good, very good. That is correct. So mod V is equals to, we can write here mod V bar equals to root of Vx square plus Vy square. Okay, that is root of 20 square plus 20 square. Yes, yes. First one only now. 20 square plus 20 square is root of 800. That is equals to 20 root 2 meters per second. And yeah, tan alpha is equals to Vy by Vx. Okay. So if I move to the next page, tan alpha direction is Vy by Vx. Vy I got in the previous page 20, Vx also 20, tan alpha is equals to 1. So from this you can say alpha is equals to 45 degrees. Tan 45 is 1. Okay. Even extra, if you want to write in vector form, you can write in vector form. Like Vx I cap plus Vy j cap. Actually unnecessary. Yeah. Okay, no problem, Nana. Vx I cap plus Vy j cap. Vx is 20 I cap plus Vy is 20 j cap. That's it. Over. Okay, this is the velocity part. Right? And here, suppose fourth one, if I ask, okay, the angle with which it strikes the ground. Okay. So if you see the diagram, you will get some idea now. Angle with which it strikes the ground means here I am asking with what angle it strikes the ground. Okay. Means he is asking while striking, suppose this is the direction of velocity, that velocity makes how much angle with the horizontal, identical to this alpha. Here alpha equals to how much he is asking. Okay, so don't get confused. That alpha you can find using the formula what? Tan alpha is equals to Vy by Vx. Okay. Vy by Vx means here what is Vx and what is Vy, that you have to find out. Okay. So here Vx and Vy means it strikes the ground in how much time, Nana? In how much? Oh, acha. That is it the answer? Okay, okay, okay. Right, good. 2 root 5. Right, right, right. You are right. Very good, Mr. Amok. So it strikes the ground in a time t is equals to 2 root 5. Yes, correct. So here in that time, try to find out Vx, Vy and use the formula tan inverse Vy by Vx. That's it, over. Or else directly use this formula. What is that? Alpha is equals to tan inverse gt by u. Directly you can use. Okay. So better I go to the last one here. Fourth question. I am writing the answer. Okay. What? Here alpha is equals to tan inverse gt by u. Okay. Tan inverse gt by u means tan inverse g is 10, t is 2 root 5 by u is 20. Is it 20, Nana? U is how much? 21, I think. 20. Correct one. Yeah. So I'm getting here 2, 10, 20 cancel. So I'm getting simply tan inverse root 5. That implies alpha is equals to tan inverse root 5. Okay, that's it. We got the answer here. Right? Then here, suppose next question, if I ask like this, second one. Example 2. Okay. What about example 1, Anna? Did you follow all the 4 questions in the example 1? Or any doubt in the 4? Clear. Very good. I think why? Because, yeah. They are direct formula based. Yeah, good. Then come to here, Nana. Example 2. In the above example, or else better we write here. From, good, thank you. From the top of a tower, sorry, of height h, um, 3 bodies, 3 different bodies. Okay. Are thrown simultaneously with the same velocity u as shown. Okay, I will draw the diagram here. Later I will draw Nana. First you see the question. As shown. Show that the ratio of velocities while striking the ground while ratio of velocity while striking the ground is 1:1:1. This is the question. I think if I won't give the diagram, you can't solve this question. So first of all, I'm giving the diagram for it. Okay. Here, suppose I take, this is the top of a tower. Okay, and it is the ground. And from the top of a tower, three bodies are projected simultaneously, he told. Okay, number one body is projected vertically upwards. This is the body one. Second body, here from the top of a tower, projected horizontally like this. Means what we discussed, just the theory. Okay, in the previous class and in today's class. And number three, from the same top of the tower, body three, okay, is projected downwards. So three bodies, one upwards, two horizontally, three downwards with the same velocities simultaneously at the same time. Okay, there is no time gap. Here he is asking, obviously while coming, first it goes up and then finally it will come down. First it goes up. Okay, better I take like this. This is the first one, goes up and then finally reaches the ground here. Right? And this is the second body. It straight away goes down. Okay. And the third body follows the parabolic path as shown here like this. Follows the parabolic path. Hits the ground somewhere here. Okay. These are the three bodies, Nana. Okay. So while reaching the ground, first body strikes here, Nana. Second body strikes here. Third body strikes here. So while striking the ground, so if I assume their velocities are, first body velocity is v1, second body velocity is v2, third body velocity is v3, show that v1 is to v2 is to v3 is 1 is to 1 is to 1. Now you understood the question first, Nana, here? Or any doubt in the question? Okay. Understood. Okay, good. So will I go to the solution part? Yes. Okay. I'm going to the solution here. Okay, no problem. Oh, I took that is second body. Sure, Nana, what is that? Simple change the numbers. Okay, no problem. I will take it as 2 and I will take it as V3. That's it. Okay. Why? Because you are saying that it is taken as third body. So no problem. V3 and take it as V2. Okay, good. Right. Then here, come to the solution. In the first body, I think second body you can say very easily. Why? Because we were in that concept only. Okay, so we are in that concept means here second one, while striking the ground, velocity v is equals to, all of you know that, root of vx square plus vy square. Okay, so here this is v magnitude, second body v2, where vx in case of horizontal projection you know that is u and vy is gt, and time taken to reach the ground is root of 2h by g. Okay, all are there, directly you can substitute. Okay, Nana? So here this is root of Vx square, that is u square, plus Vy gt whole square, that is equals to root of u square plus g square into t square, that is root of 2h by g whole square. Okay, total time of flight. So this is equals to root of, look at here what we are getting, u square plus this is g square. Here root and square get cancelled. So you are getting g square into 2h by g. 1g get cancelled, Nana. You will get 2gh. So V2 is equals to, I got here root of u square plus 2gh. This is V2. Exactly. Beside V2, I got the answer. Okay. Any doubt in my explanation here? V2. All of you understood how to get V2, Nana? Clear. Okay, good. So no problem. Right. So here, come to V1, Nana. V1, try to recollect. This is the part what we discussed in the previous chapter, motion in a straight line. When a body is projected from the top of a tower, okay, total displacement S is equals to minus H. Try to recollect, Nana, when a body is thrown vertically upwards from the top of a tower. So S is equals to minus H and it is projected upwards. Okay, initial velocity U. I am asking final velocity. So I am going to use motion in a straight line. V square minus U square is equals to 2AS. Okay, V. First body, velocity is V1. V1 square minus U square is equals to 2 into, it is thrown vertically upwards. Upwards means A is minus G into S is minus H. So understood this step, Nana? Yeah, good. Oh, yeah. You are right now. Okay. So here, this is, right. So V1 square minus U square is equals to minus of minus plus 2GH. That implies V1 square equals to, taking U square to the other hand, U square plus 2GH. Yeah, that implies, uh, can't we use it? Which displacement formula, Nana? And to find out what, V1 or V2 or V3? Which one you are asking, Angel? Okay. V1 equals to, we are getting root of U square plus 2GH. Respond, Angel, Nana. Why? Because I did not follow what you asked there. S is equal to ut plus half a t square. That time we don't know, Tali. In the second part or first part or third part, second one time you don't know. Right. That's why we are using, since we know the displacement from the top of the tower to the ground, we use this formula. Yes, good. Fine, Nana. And this is V1 and V2 already we calculated. This is V2, Nana. And we are coming to V3. This is very easy, damn easy. Directly thrown vertically downwards. Directly thrown vertically downwards means in the third case, okay, S is equals to H straight away, the displacement. And going down, A is equals to plus G in case of third one. Okay. Therefore, again, a motion is straight line. So I can use the formula V square minus U square is equal to 2AS again. That implies I'm going to get V, this is what, V3. V3 square minus U square is equals to 2. A is plus G, S is H. Look at here, you are getting the same thing here. V3 square is equal to, by taking U square to the other hand, U square plus 2GH. That implies V3 equals to, I got under root of again, U square plus 2GH. Okay, look at V1, V2, V3. All the three are equal or not, Nana? Equal. Yes, correct, correct. So V1 is equal to V2 is equal to V3. Yeah, good. So I think nothing to explain. What will be the ratio if they are equal? 1 is to 1 is to 1. Very good. Over. Therefore, in the next page, final answer. Therefore, we write here V1 is to V2 is to V3 equals to 1 is to 1 is to 1. Yeah, good. So do you have any doubt or questions in this problem, Nana? Example 2? No doubts and any questions to ask? No. Right. Good. Good. Right. Very good. Very good. Okay. This question was given previously in exam. Okay. One, two, three, three bodies are projected. Actually, he gave only two bodies. Body thrown vertically upwards, the body thrown horizontally like this. Okay. He gave that in the two cases, the velocities are V1 and V2 while striking the ground. Just added one more. Yeah. No problem. Okay. You can understand Anna once you see that after completing the class. It is easy one. Right. And then come to here. Problem number 3 now. Right. Now come to here. Example 3. Okay. This one try to understand properly. Okay. Example 3. An aeroplane. Aeroplane is flying horizontally obviously times are different, Nana. Times are different, but velocities I asked. They reach the ground with the same velocity. Lakshmi Gayatri. Two bodies are thrown downward. Okay, okay. Different height, then they will not reach. Obviously, that is correct only. But here we found the velocities now, that too from the same height. Okay, right. Now look at this question. Nana. An aeroplane is flying horizontally with a velocity. Try to recollect the conversion, Nana. How to convert kilometers per hour to meters per second. Okay. Why? Because he gave the velocity in kmph. Right. In the meanwhile, try to recollect with a velocity. Yeah, into 5 by 18. Very good. That is correct. With a velocity of 540 kmph. Okay. At a height of here say some 250 meters. Okay, almost 1/4 kilometer. Okay, 250 meters. Take g is equals to 10 meter per second square. Okay, like a fighter plane, Nana. This is one fighter plane. Fighter plane generally releases the bombs. Okay, to reach the destination. But here, unfortunately, he is a new person who is here the pilot of this aeroplane, and unfortunately, he released the bomb from the fighter plane just above the target. Okay, so that question he framed here with a velocity at a height of 250 meters. A bomb is released from the plane. Okay, maybe from the plane when it is above the target. But the question is, I did not complete the question, Nana. The question is, find the distance on the ground where it hits. Okay, means after releasing, it hits the ground somewhere, Nana. From there, okay, of course, where it better we write like find the distance where it hits. That is better. Find the distance where it hits. It's from the target. This is better. I think you can understand. Okay. First, try to understand the question, Anna, here. I will give some diagram and help. Here, suppose one fighter plane, okay, is correct only, is flying horizontally. Okay, when it is just above the target, this is the target, Nana. Okay. Yeah, good. Nice. Above the target, suppose this is the target A. Above the target, the fighter plane is just at the point B, releases the bomb. My question is, that bomb, I think, won't fall vertically downwards. Okay, is it correct, Nana? Yeah, projectile motion means after releasing. Why? Because plane is flying horizontally. That's why after releasing, the bomb also flies horizontally like this. Yes, correct. Okay. So the bomb flies horizontally with the same velocity of the aeroplane, Nana. Same velocity means the initial velocity. Yeah, that is correct. We have to find the range only, Nana. Now you understood. Yeah, Amok, correct. Lakshmi Gayatri also correct. Yeah. Here the velocity is equals to velocity of the plane, aeroplane. Okay. That is 540 kmph. Okay, I think all of you converted that one. All of you know that here in the solution. The initial velocity is equals to 540 kmph. That we can write it as 540 into 5 by 18. Okay. That is 1830s. That implies u is equals to, correct, 150 meters per second. Nothing wrong in it. Okay. And as usual, when the bomb, after releasing from the plane, it flies horizontally and hits somewhere here. Okay. Just he is asking what you understood. That is correct only. Where it hits the ground. Okay. From the target. This is the target. It hits at C. Means indirectly he is asking the range. Yeah, you are right. Okay. 100%. So he is asking AC, Nana. So AC is nothing but range, that is equals to, all of you know. If you understand the question, it will be very easy. Root of 2h by g. That's it. So 150 into root of 2h is how much? 250. Sorry. 250 by g. 10. So this is 5 taken out. 25. Under root 25 is 5. 15 5s are 750. Okay. Under root 2. Yeah. 750 root 2 meters. This is the distance where it hits from the target. from A. So understood this question and all of you? Yes, good, good, good. Now, will I ask, very good. Will I ask here in this problem? This is example 3, I think. Yes, correct. So, in example 3, find the relative velocity of bomb with respect to pilot. Then what do you say? Try to recollect here what is relative velocity now. Okay. Relative velocity also we discussed in the previous chapter, motion in a straight line. Relative velocity comes under subtraction or addition, Anna? Wow, 150 meters per second. Is it so? I think wrong. It is wrong, Lakshmi Gayatri. I am asking relative velocity. Yeah, correct. Relative velocity, it is wrong. That's why I'm asking. Try to recollect, Anna, no problem. Okay. Relative velocity, previously we discussed velocity of one body with subtraction. Yes, correct. No need to put any question mark there. It is correct only. Right? So here the relative velocity, yeah, correct, subtraction only. Relative velocity, okay, of bomb with respect to pilot means I have to write velocity of bomb with respect to minus pilot, velocity of pilot. Okay, I think bomb path and the pilot path, I think they are different. Both are traveling in two different directions. Am I right, Nana? After releasing the bomb falls on the ground or pilot falls on the ground? The bomb, not the pilot, I think. Yeah, pilot will go along with the aeroplane. That's why pilot travels in this direction. Yeah, and bomb travels like this, parabolic path. Right, good. So here, these directions are different means better you take in vector form, Nana. Why? Because their directions are not same. Okay. Consider, for your sake, I am giving some sign convention, means coordinate system, Nana. Take it as x-axis and take it as y-axis. Okay, now I think you can say very easily. Pilot is moving along which axis, Nana? Along x-axis? X-axis. So velocity of pilot, very easy to write here. Velocity of pilot is nothing but velocity of the aeroplane. Yeah, geometry only, Nana. Correct. Here, that is 540, which is 150 meters per second. So this is 150 meters per second along x-axis, vector form I can. Okay, good. And here, velocity of this one already we know. Vector form, V bar of the bomb following the parabola here, that is Vx I cap plus Vy j cap. Okay, Vx is again U I cap plus Vy is Gt j cap minus 150 I cap. Okay, so here you observe U is 150 only, Nana. 150 I cap plus Gt j cap minus 150 I cap. Okay, so here look at 150 I cap, 150 I cap get cancelled. Then you are seeing here this is equals to simply Gt j cap. Yes, Gt j cap. So you are getting the relative velocity in what direction, Anna? Along y-axis. Very good. Are you finding any relative velocity along x-axis? No. That's why here the conclusion. Can I say like this? Yes, correct. Okay. Here that implies along y-axis, sorry, along x-axis, there is no relative velocity. Okay. There is no relative velocity means observe properly, Nana. After releasing, when the pilot comes to here, the bomb, along x-axis, there is no relative velocity. Exactly below that pilot. When the pilot comes to here, the bomb exactly comes to here. When the pilot comes to here, the bomb exactly comes to here. Yeah, okay, that I accept now. Okay. What I am trying to say here is when the pilot sees the bomb, all the times along x-axis there is no relative velocity. That's why the bomb will appear below the pilot only. Okay. When the pilot comes to here, the bomb is exactly below the pilot, it hits the ground somewhere here. So my question is, can the pilot see the bomb where it hits the ground or not? Can he see the pilot, Nana? Can he see? I no. Why no, Mr. Akhil? Yes, why? Because bomb is just below the pilot only. Okay. Of course, I think you are saying that when he focus more on driving, then he can't see. If he want to see the bomb, he can see that bomb. Yeah. Okay. Right. So see here. Okay. So can I write here that implies the pilot can see the bomb. That's why I'm saying here can see the bomb. Yeah, obviously he can see. Why? Because here while listening the class we chat with our friends or not. Okay. Why? Because all we are multi-talented. So the pilot is also multi-talented. So the pilot can see the bomb. Right, correct. Okay. See the bomb because it always appears 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 below the pilot. Okay, no problem. Good joke. Right here, Sarath, Mr. Sarath. Okay, then this is, and you are saying that that implies along y-axis. Already Lakshmi Gayatri put the answer there. The relative velocity that is equals to, in the previous page I wrote, it is gt along y-axis, and she put the answer. Okay, g into before hitting the ground. Okay, she told the relative velocity after before reaching the ground. Okay, g into root of 2h by g time before reaching the ground, or better I write just before reaching the ground. Okay. uh, Here that is equals to g is 10 root of 2 h is 250 by g is 10. Okay, 5 taken out, that is 50, 25 taken out, no, that is 550 root 2 seconds. What is this relative velocity? Sorry, meters per second. Okay, right. Did you understand this theoretical concept, Nana, what I wrote here? Or any doubt in this theoretical concept? Okay, no problem. Yeah, right, good, 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 good. And here today we are coming to the last problem. Okay, yeah, that is example 5. Okay, here the question is like in the movies ready, very good, Ishan. It's too late. Okay, I think it is the mania of leaving the class, not phobia. Mania of leaving the class. That is the Josh coming from leaving. Am I right, Ishan? Okay, good. Come to here. This is the question. From the top of a tower. Okay, means he's a stunt master, Nana, like in Doom series. Okay, Doom 1 or Doom 2 or Doom 3. Okay, okay. Right, no problem. From the top of a tower, here one stunt master, okay, leaves a hill from the edge. Yeah, right, correct. Okay, you said that you leave, still you are there. Okay, here with the velocity u is equals to like 108. Okay, good number, kmph. Okay, and exactly leaving the edge, live on the edge. Here leaving the edge and here coming into air. Okay, from one hill, since he is the stunt master, obviously he lands on the other hill, not fell in the valley in between the two hills. He follows one parabolic. Oh, one parabolic path here, and finally exactly lands on the other hill. Okay, good, good, good. Right. So here, if I give the width of valley, okay, between the two hills is say 500 meters, okay, then here what is the difference in the heights of the two hills? Okay, question is h1 is the height of first hill and h2 is the height of second hill. Then the question is h1 minus h2 is equals to how much? Quickly, it is turning around 4. Okay, how to solve this question? Got any idea? Okay, bye now. H1 minus H2. Got any idea? Simple related to this. Oh, good. Where is cos theta, Ratali? Simply watch properly. Here he is asking just the difference between the two heights means I think he is asking only this much part. Okay. That is exactly like the height of a tower when a body is projected horizontally. Yes, I think you are right, Mr. Amuk, but I have to check. Yeah, you both got same answer. Very good, very good, very good. So here, this is just like H Nana. From the top of a tower, when a body is projected horizontally, it hits the ground at a distance. Yeah, I think it is correct. Lakshmi Gayatri and Amok. Okay. Why? Because you both got the same answer. On that belief, I'm saying. So solution, simple. Quickly we try to finish it, Nana. The range, distance between the two valleys, R is given as 500 meters. Okay. Height, which is the difference between the two heights of the tower. H, we require, which is H1 minus H2. Okay. And here from the top of the tower, horizontally projected U 108 kmph. So 5 by 18. I think you did not convert this 108, Nana. Converted this 108 into meters per second. You both converted. Okay, okay, okay. Then I right. 18 6 108, that is 30. Yeah, okay, correct only. 30 meters per second. Then our formula R is equals to U root 2H by G. Okay, R, that is 500, U is 30 into root of 2, H, I don't know, by G, 10. 0, 0 cancel here. Okay, so squaring on both sides, 50 square is, here Sharath. Nana, very frequently you are opening your video. Oh, want to show? Right, you are correct, Nana. 50 square. Okay, no problem. 50 square is equals to 3 3s are 9 into 2h by 10. That is 2500 is equals to 9 2s are 18 h by 10. Okay, that implies h is equals to, by taking cross multiplication, 25,000 by 80. Okay, that is 12,500. How much you both put the answer, Nana? Yeah, that is correct. 12,500. Correct only. So 2 nines are to 12,500. So h is equals to 12,500 by 9 meters. Correct only now. This is 100% correct. Okay. So understood now all of you? 4,500. Yeah, 12,500 by 9. This is correct. Rachuri, you got different answer? Yes, I think this is correct. So shall we leave, Nana? Or do you want any pages? You can ask if you want. Or pages. Okay, sure. This is first page, Ratali. Thank you. This is second page. Thank you, Nana. This is third page. And this is fourth page. Of course, one more page is there. No. This is the last page. Okay, Nana. Bye, everyone. Okay, Nana. Bye.